For this video, we are going to be dealing with acceleration, velocity, and position, and as well as integration, of course. So let's get started. A bee slides down a ramp that makes an angle of 5 degrees. Okay, so, and there's no friction or air resistance. That's good. We don't have to calculate or deal with coefficients, and so the only force exerted by the ramp is a force that cancels the component of the force of gravity perpendicular to the ramp. Okay, so we'll get to that if you don't understand it yet later, after we draw the picture. So how far does the bee slides in 6 seconds? So it's asking 6 seconds if its initial speed is 0. Okay, so we can write down some of the things that we are given. We know that the angle of the ramp is 5 degrees, right? And then the question is asking for, we want to find like the x component. We don't know when t is 6 seconds. Okay, and then we also know that the initial speed. So let's draw a ramp first. So here we have a ramp, and then it says the angle is 5 degrees. For now, I'm not going to put in any numbers. I'm just going to use everything symbolically. It'll make life easier. So here we have the normal force, right? And then the normal force is actually counterbalanced by the force of the weight, which is just mg, okay? And then here we have another force. So we have to consider the two forces in the y and x direction. So in this case, the y direction is obviously this way, and the x direction is going this way. So y up, x towards the right. Okay, and from here, due to the because these triangles are similar, we can say that this angle is the same angle as that, which is 5 degrees. And in another video, I can show why this is true. Okay, so now we want to know, let's fill out the rest of this triangle here. So in this case, we know that the weight is, because so we want to find this part right here, and then this part right here. So we can use SOHCAHTOA. SOHCAHTOA, right? SOHCAHTOA. So opposite, so this will be sine over hypotenuse. So this is actually the hypotenuse, the weight. So it'll be F, oops. Okay, so we can write F of W sine angle, right? Okay, so F of W cosine of angle. Okay, so now we have both of our legs, the length of both legs, and the hypotenuse. So what's the next step? Okay, well, we can solve this problem by using Newton's second law, which says F equals ma. You might be wondering why, but you'll see this is very neat. Just imagine, like, you can solve this entire problem with this very simple formula right here. Okay, so let's get started. And with this continuation of this, so we have the force, but everything is in terms of time. Just remember, terms of time. Okay, so another way to write this would be, because mass doesn't have time, well, it doesn't depend on time. Only acceleration and the force does. Okay, so here we can say force is a vector, so is acceleration. So in this case, we have our components of x and y. You want to take a guess what it might be? Well, the x component, we have it right here. And so we have the y. So we can just fill this in. So I'm just going to write mg in replacement of f of w, which is the force of weight, mg sine theta, comma, mg cosine theta. Okay, so what's the next step? Well, do you see something? Well, I certainly see that we can cancel the m out, so we don't need to worry about m. And plus, the problem didn't even give us the mass of the bead. So let's rewrite this. Oh, can't really see it, can you? Okay, let's go down here and sine of this. A. Okay, acceleration, because the mass is canceled out. So now that we have acceleration, and perhaps from your lecture or from the textbook, we know that when we integrate acceleration, what do we get? We get velocity, okay? And then when we integrate velocity, what do we get? We get the position. So vice versa, when we take the derivative of the position, we actually get the velocity. And when we take the derivative of velocity, we get acceleration. So now we have the acceleration in vector form. And this is good because recall what the question is asking us is that how far does a bee slide in 6 seconds? Well, it's asking us how far, right? So how far? We can solve for x and y. So, but for the sake of this problem, I believe they only wanted the x component. So this is perfect because we have it in vector form. All we have to do is integrate it and maybe perhaps plug in some numbers. So let's integrate this. Let's integrate. I'm going to take the g out. So when I integrate sine, I get sine. So I can remember that everything is in respect of t. So we have negative cosine theta and t, don't forget about that, and then we have a constant, okay? I'm gonna erase this. Okay, so and then the next thing is when we integrate cosine, we have sine theta t plus some constant. So constant 1, constant 2. Okay, so now we have this, right? So actually when we integrate this, what is this? Well, we just said it. It's velocity. Or v of t equals... Now I'm just going to put in the g. It's easier for me to see. Oh, oops, this is a plus. Sine theta t plus c2. Okay, let me see something. Okay, so now we have velocity. And recall the question, we're given that at the initial velocity, so when initial velocity means that when v of 0, right? When v of 0 is, it's actually just 0, 0. That's what is said from the problem. So now we have to do is equate the two. Okay, how do we equate that? Just in case if you don't remember. But, so all you have to do is set 0 equals to negative g cosine theta. But in this case, t is 0. So this actually goes away. So c1 is 0. And then we do the same thing for the other one, see, and then it goes away, the g of sine theta, t, it goes away, so we're just left with c2 is 0. So the new velocity after equating, it's just t. Oh. Oh man, okay. Okay. Okay, g sine theta plus, oh, that's a t. That's it. Now we have this, okay? Now we have this. Now we have this, okay. So what do we do? Well, we want to find the position. So now we just integrate this again. And what do we get? We get negative g. Well, when we integrate cosine, right? Negative cosine, what do we get? Okay, we integrate negative cosine, we actually get sine, okay? And then t2 over t squared, and then we have, what's sine? When we integrate sine, we get negative cosine theta t squared over t. Okay, so now we have the position, perfect. So now, we're almost there. Let me go up here and let me erase this because I don't have any more space on the bottom. Okay, so now we have the position, right? So usually I like to label it as R. Oops, I forgot the chain. And let's just plug it in. Well, here's the trick. The trick is that, where is that? Because due to the different unit measurements, we can use different, we can use either g equals 9.81 ms squared, or we could use the British pounds of the gravity, which is 32 point, I think it's 2 or 3, 3, and then feet per second. So in this case, we're going to use the British pounds just to spice things up. So that, and then sine 5, and then times 36, because time, we want to find out when time is at 6 seconds, right? And then you divide all of this by 2. And we can also do the same thing for the y component. So let's do that really quick. Oops. Okay, so the answer would be 52.2 feet, which is in British pounds, and that's in the x component, and I want you to find out what the y component is, okay? So work on this, yeah, all right, thank you.